all we start. I agree. Let's get going. Okay, so what I want to do is I want to talk to you about the topic of fractions. And I have in front of me a number line. And a number line was a big deal in the last lesson. Now, I want you to put in the chat, what type of fraction is 0.4? I want the word for it. What is that called? I want you to type it in the chat. Okay. Yes, this is called a decimal fraction. Absolutely. Okay, so this is one of the types of fractions we have to get comfortable with. Okay, now I want to know, what is the green type of fraction called? Where I put the green line now. Okay, I'll give it a bit of time. Pop your answer in the chat. Tando, yes, I see that. Mbali, I see that. Yes, this is called a percentage. Oh, excuse me. Percentage, yes. And that's another type of fraction. What's special about percentage fractions? What makes them a little bit different? Does anybody know what's special about percentage fractions? Anybody? They have a Q. Yes, they do. They are always over 100. Exactly. So when you see 40%, that's actually saying it's 40 over 100. The percentage symbol just means a denominator of 100. But we'll get to that in a moment. Well done. Yes, Amakle, you have got it spot on as well. Now, we'll come back to decimal fractions in a moment. What type of fraction is this one at the bottom? 4 over 10, or what type of fractions are these? 4 over 10 or 2 over 5? You guys are on fire. Okay, there's actually two words we could use. The one is that they are common fractions, and they are two common fractions that have the same value, and so they're often called equivalent fractions. Okay. Perfect. So this is some of the basic vocabulary of fractions. Now, what I want to talk about is just quickly the decimal fraction. If I had something like 0.4, let's do this quickly. If I had the number 0.42, could you write that as a common fraction for me? So I've just made up a fraction that's similar, 0.42. What would that be as a common fraction? Let's see if you can translate between the two types of fractions. So I want you to write this 0.42 as a common fraction. I want you to write it in the chat.
Sir?
Yes?
Also want to show learners, when we work with common fractions and you want to type, you can do what Ria Betsway did, where you use the /, and that also means like a division symbol, like Sir's writing on the board now. That means exactly the same. Or you can say over if that's quicker for you to type.
Yeah. So it's worth doing notation that 0.42 is 42 over 100. And so this is, if we can do that, we can translate between the two systems. Nice, Tando. Nice, Vasedi. I want to do another one. If I gave you 0.523, could you write that as a common fraction for me as well? So I'm testing, can you go between, I like it, now you spotted what I'm after. I'm testing you guys. So what's important to notice is that if I have 3 numbers after the decimal point, I'm no longer going to have 100 as my denominator. Rather, it's going to be over 1,000, because 10 to the power of 3 is 1,000. And so this fraction would be 523 over 1,000. And so when we look at decimal points, if there's one decimal place, like at the beginning, 0.4, it would be over 10. 0.4 is just going to be the same as 4. Oh, I've made a mistake there. Made it angry. There we go. So 0.4 is just going to be 4 over 10. Okay, let's do one more thing before I move on. If I said to you, write 0.68, actually, write 0. I want you to write 0.6 as a percentage. I want everyone to write 0.6 as a percentage. What would that be as a percentage? As a percentage. Now, I've changed the word. See, I'm getting sneakier. 0.6. What's that as a percentage? Aha. I see lots of interesting answers now. Okay. So yeah.
Before you carry on, I just really want to give, I know you asked as a percentage, but Kai Ligle, I really want to say thank you because they first changed it to a common fraction.
Yes, like that.
10. That's the only thing I want to bring to light because that will help you with what Sir's going to explain now. All right, so back to you.
So important because what you need to think about is 0.6. If I want to write it as a percentage, remember a percentage has always got a denominator of 100, or it's over 100. Now, the problem with 0.6 is actually when I write it as a common fraction, it's 6 over 10. And now the problem is you see straight away when you do that you can't write this as 6% because it's not 6%. What I need to do is take this and convert it to a fraction where the denominator is 100, or convert it to an equivalent fraction. So what did I do to get from 10 to 100? I multiplied by 10. And if I wanted to stay the same fraction, I have to do the same thing to the top and bottom. And so 0.6 is the same as 60 over 100, which we can then say is 60%. So there's a very important lesson in this. The lesson is that whenever we are converting from a decimal, we need to first go into a common fraction, and then from there go into percentage, unless we've already got 100 at the bottom as the denominator. Okay, then the other important bits with a fraction. The special names. There's a special name for the number at the top and a special name for the number at the bottom. I want the name of the number on the top in a fraction. What's the special name? In the chat. Yo, Lenovo on the ball. Kayelihle on the ball. So this is called a numerator. Yes, Kayla, well done. Trevor Tokozani, you're on the ball. Okay, now, I think you kind of know where I'm going with this. What is the number on the bottom called? Okay, too easy for you guys. This is called the denominator. And actually, if you trace it back to the root of the word, denominator just means like your family name. And so it's kind of like the family that you belong to as a fraction, whereas the numerator is just the name of. Okay, now, since you guys have got the basics of fractions down, what we normally do when we deal with fractions, we often have what's called a visual representation. So if you look at something like this, they often do things like pizzas. And we might say something like, well, if you want to visualize a half of a whole, you can kind of see it as half of a pizza, a quarter like this, and 3/8. But you can also visualize fractions using other shapes. So let's say I do it like this. Now, I know I haven't drawn it perfectly, but what fraction have I just drawn? We'll call this A. What fraction have I just drawn with A? Visually. Assuming my rectangle bars are the same length. Ah, yes. 1/3. Okay, fantastic. So here comes the problem in mathematics. What happens if we want to add something like a half over here, and I want to add it to my thing over here, then what I have is I have the question a half plus a third. And a half plus a third, visually, you can easily see the half relates to like a picture like this, third like a picture like this. But now it's not so simple to know what new fraction you get if you add those two things together. Does anybody know the word or the process we might use to add these two fractions together? How can we make them one fraction in total? I want to see in the chat. You have to multiply the denominators and then cross multiply. I think you're onto something there, Charity. Okay, let's see what else. LCD, lowest common denominator. Okay, simplifying them. I like where we're going with this. Keep coming. So what I want to suggest the problem is, yes, the problem is that this one belongs to the family of denominators with 2, and this one belongs to the family of denominators with 3. And if you don't have the same family name, we can't add the fractions together. So we have to do something in maths where it's called creating an equivalent fraction. And sometimes we say finding the lowest common denominator, or the LCD, the lowest common denominator. Also, if we go back to the very first unit of the year, it's what's the lowest common multiple of the denominators. So basically what we're going to ask ourselves is, what is a number that both 2 and 3 go into? Or that what is the lowest common multiple of the denominators? So if I wrote out 2, I get 2, 4, 6, 8, and so on. And then for 3, I get 3, 6, 9, 12. We can see the lowest common denominator that's possible with these two is going to be the number 6. But we've got a problem now, because at the moment, our fractions don't have denominators that are 6. They have denominators 2 and 3. We'd like to change them to have denominators of 6. And so what I'm going to do is I'm going to say, well, what do I need to multiply 2 by to get to 6? And I'm going to multiply 2 by 3. But if I left the denominator 3 times bigger, it's no longer the same fraction I started with. So I have to multiply the top by 3 as well. And then what I have is I have a new fraction. The fraction below is going to be 3 over 6. Now, on the top, for the other fraction, I'm not going to multiply by 3. I ask myself, what do I multiply by 3 by to get 6? I multiply by 2. And 2. And what do we get then? We have 2 on the top and we have 6 on the bottom. And now both of them belong to the family name of 6. And so we go 3 plus 2, we're allowed to add them, and we get 5 over 6. Now, this traditionally is something that students do struggle a little bit with, and it's because they don't understand that you can only add fractions if they have the same family name or the same denominator. But in order to do that, you have to first make equivalent fractions with that denominator. And so that's what we're going to start with practicing today. I'm going to practice this idea, but in fact, before I move on, are there any questions or comments before we start the first proper exercise of the day? So far we've done the different types of fractions, and now we're looking at we're looking at common fractions, and how do we add different types of common fractions? Okay, I'm not seeing any questions yet, so we're going to move on. So I'm going to set you these 4 questions. And do you need to simplify your answers, Scarlett? If you can simplify them, that would be good, but we don't have to at this stage. It's now 17:24. I'm going to give you until 17:29 or 5 minutes, and then I will give the full answers. I might give a few answers before that, but over to you guys to show me, do you know how to do adding fractions with common denominators? That is what we're checking. It's a foundational skill that you even use in grade 11, guys. When you do things in grade 11, you still use common denominators. So we have to get it nice and right for now.
So,
and for me, yes.
I see we have a question from Yandisa.
Go ahead, Yandisa.
Afternoon, sir. Afternoon, ma'am.
Hello.
So, sir, I was asking, sir, since you are asking for the answer for the
Not yet.
common
We
factor.
want to give a little bit more time, Yandisa. If you could put the answer in the chat for now, I want to give students a little bit more time.
And
Okay.
then
Yeah.
Yes, sir. So, sir, should you show the decimal fraction also?
No decimals yet. We're just focusing on common fractions for now.
Yes, sir.
okay, thank you, Yandisa. And then, so before we take the next question, I know it's a bit difficult, but can you zoom in so that it's only question 1 to 4? So the top where it says calculate, can you maybe just get that out of your screen?
How's that?
Okay. Just a little bit more up. There we go.
That good.
Yeah,
Okay.
if the learners can see that. Okay.
Perfect.
And I see Scarlett's hand is up.
Go ahead, Scarlett.
Hi, sir and ma'am. I just wanted to know, I know you said that we don't need to simplify, but for improper fractions, if it's an improper fraction, do we like have to?
Okay. For now, I'm going to leave that vague because I haven't spoken about improper fractions. So for the moment, I want you to do whatever you want to do with them. I will specify, I'll talk about improper and mixed numbers in a moment. But for now, I'm just going to let it be like, do what you think for now. Okay. I don't want to complicate too many things at once to start with. But you are absolutely welcome to simplify to that degree. Okay, how much time we've got? We've got 2 minutes. I am going to do the first one because luckily in the first one, the denominators are the same. And because they are the same, it's actually nice and simple. We just go, it's 6/7. Yeah. And using the same reason, because the denominators are the same in the second question, we can go straight away, it's just 9/8. Now, at this stage, if I haven't said anything more, you'll notice that the number is on top is bigger than the number at the bottom. And we call this an improper fraction. However, there's nothing wrong with having that. But if your teacher wants you to leave it as a simplified mixed number, we would then say 9/8 is actually the same as, well, 1 and 1/8. Basically, it's made up of these two things, 8/8 and 1/8. And we know that 8/8 is just going to be the same as 1. So you could write it as 1 1/8, in which case it's called a mixed number. But at this stage, I didn't specify. Murdy, your hand's up. Go
Yeah,
ahead.
sir. I would like to answer for number 3.
Go ahead. Guide me through your
Okay.
thinking, Murdy.
Okay, sir. So the denominator, the lowest common denominator for 3 is 12. And then when you say 12 down, then you put a cross on top, you put a line, and then you say 3 plus 2, which is 5, and then the answer is 5/12.
Okay, let's just make sure I've got all that. So if I multiply the bottom by 3 and the top by 3, I get 9/12. If I multiply on the second fraction, let me just zoom in actually so everyone can see. In the second one, 4 on the top and multiply by 4 on the bottom, I also get 12, but now I'm going to get 8/12. Now that I've done that step, my denominators are the same. And so I can add the 9 and 8 together and I get 17/12. That is an improper fraction as it's currently left because the numerator is bigger than the denominator. If you want to write it as a mixed number, you go, how much, well, basically, how many more than 12 do I have on top? I've got 5 more, so I can go 17 minus 12 is 5. And I get 1 5/12.
So,
Yes.
may I jump in here?
Please.
When I listened to Murdy's explanation, and thank you, Murdy, for contributing your answer. Murdy, you got it spot on of getting your lowest common denominator as 12, but I listened carefully to what you said. So then you got a denominator of 12, which is correct. But you then said 3 plus 2, which gives you 5. Okay? Now I want to know who in the chat would have done the same, and it's fine.
You want to see who, because that's just, you have to watch out. That's why I do the extra step where I first get my equivalent fractions and then I get to that step there.
Okay, and then the rule of thumb is basically that I want to also reiterate in this lesson is whatever you do to the denominator, because in your mind you basically said 4 times 3 gives you 12, ne? So what you do at the bottom, you have to do at the top, and that is the rule of thumb. Okay, back to you, sir.
So Charity wants to answer question 4. So I'd like Charity to come online, please, and give us some guidance as to how we did it. This is a bit of a tougher question because the denominators are a little bit more difficult. So just tell us how you did. Charity, give us the answer there.
Okay, hi, sir.
Hi, Charity.
I just wanted assurity if you could hear me properly.
Okay.
Okay, so I got the answer by multiplying the denominators,
Okay.
which is 35.
So you multiplied the top and bottom by 5 here on the first
No,
one.
I multiplied both the denominators together, and then I got
Oh,
35.
okay. So you went straight to 35.
Yes.
Okay.
And then I cross multiplied the denominator from the left and the numerator from the right, which is 14.
Okay, hold on. So let's be careful there. How did you get 4? Did you say 14?
Yes, I multiplied the denominator from the left and the numerator from the right.
We must be
Which
quite
is 7
careful
and
here.
2.
So, because what you need to do, I want to see if you get the same as me. If I multiply the first fraction on the top and bottom by 5, I get 25 over 35. And then for this next one, in order to get to 35, I multiply this by 7, which is the same as your cross multiplying.
Yes.
But Charity, I get 14 over 35. So did you get that?
Yes, I did.
Okay. And now what's the last step?
And then you add the numerators, which is 39.
Yes. And if you had to simplify it to get to take it from an improper to a mixed number, what would you do?
Then you need to say and then you need to divide.
Okay, so you got 39 divided by 35 and you get 1, but how much have you got
1.
left over?
4 and it's 1 and 4 over 35.
Yes, well done. Perfect. So that was really good because that's getting quite a bit harder. And I want to just quickly go through the key steps that I did because I think not all students will have got this yet. When we started this question, really tough bit. Okay, if we could just ask you to be on mute if you're not answering a question. When we started, the really difficult part was really the 7. Oh, excuse me. Come back number. The really tough part was finding out what common denominator do we have, and what Charity did was she said, well, I can get that by just taking 7 times by 5. So she got all the way to 35, but there was still the problem of how do you make the equivalent fractions? How do you work with the 5 over 7 and the 2 over 5 to get to the 35? And that's where she said something called cross multiplying. But I like to say, and it's not wrong to say that, but what number do I multiply 7 by to get 35? And the number that I'm going to say is it's going to be 5. Oh, that 5 is rather large though. It's a little bit too big. So I just want to emphasize this. But when I multiply the bottom by 5, I can't leave it there. I have to also multiply the top by 5. That way it's still the same fraction. And that's how I got 25 over 35 above. Now I then did the same thing to the next fraction, but that idea of making equivalent fractions is really, really important because once you have equivalent fractions, then the adding together of the denominators is much easier. How I got 4 over 35? Rebetswe, good question. So Rebetswe is, Ms. Anya's on it already. So basically, what you do is you say, well, imagine 39 over 35. It comes from 4 over 35 plus 35 over 35. Take it for a moment and look at that. If the denominators are the same, which they are, you can just add them together. So 4 plus 35 would be 39. Now, what is 35 over 35? It's just 1. And so then I'd get 1, which is and 4 over 35. Another way of saying it is saying, look, if I took 35 away from 39, then taking the 35 away gives me the 1. And then how much is left over? There's just 4 left over after that. Okay. All right, guys, I think we've earned a break. And so I want everybody to stand up for a second for me. And we're going to have a brain break. But I need you to stand up before we move on. And what I'm going to ask you to do is my favorite one. Hopefully you can still see me. So you get a pen, and for those who are new to this, you may wonder what is going on with this rather odd math teacher, but we're going to do something called a pen flip, which helps our brains get away from maths for a second. And for those who've been doing this for a while, I only want you to use your non-dominant hand now. You're not using your right hand. If it's your first time today, you're allowed to use your dominant hand, and you need a pen. So grab a pen. And what you're going to try and do is you're going to try and flip the pen so that it only spins once in the air and you catch it at the same end. So I'm going to try and catch it on this end over here. And it's called a pen flip. If you've lost me for a second, Miss Anya will try her best to explain it in the chat. Miss Anya, am I still with you or not?
Yeah, sir, I've got you everything. It's all good on my side.
Okay, that's fine. Okay, let's do the pen flip. So we take it and we catch it on that end. It helps if you have a thicker pen. Now, there we go. And for those who are new, you're allowed to use your right hand and you just catch it. See if you can do that. I'm getting quite good at this, but I'm cheating because I know it's much easier if you have a marker. Turn your cameras on, guys. I want to see you doing it. I want to see who can do it properly. Miss Anya, I want you to also look. And if anybody can do it properly, I want you to give them a shout out.
Will do.
Who can do it? So you want to toss it in the air. Ooh. Okay, I'm going to get some water. Okay. I think it is time to return. Charities looks like she's doing well. I could see that. That was looking good. Who else was doing it nicely? Okay, if you managed to do it, be honest now. If you managed to do this properly, I want you to give us a hand, like a thumbs up. And if you did it, in fact, even if you, let's see who managed to do it just once, basically to get a spin once and then catch, then give yourselves a thumbs up. And if you tried, but you couldn't quite get it, give us a smiley face. Because you tried. Last week I struggled, today I did it perfectly. Charity, I saw that. I saw that you did well. It's just, the real trick, guys, is to have one of these, let me get my thing, is to have a slightly heavier pen. And remember I said last week that in future, if you can think of a cool brain break, I'm going to come to you guys in future weeks so that you can actually lead us through a brain break. Okay, cool. Then I think it's time to move on. So For the next 4 questions, we're going to move to subtraction. And so same idea, but you are going to take the same idea and see if you can handle it as subtraction. I'm not going to give extra hints at this stage. We will respond if there are questions in the chat. It's now 1740. And I will give you till 1744, 544, 4 minutes to do that. See what you can do using the same ideas from earlier on. Okay, Shakira, your hand's up. Is that just because you could do it properly, or is there a question there?
So I have a question.
Go
In
ahead.
that other sums that we were doing, why did we multiply? You know, when the denominators was not the same. Why did we
Yes.
multiply? Were we not supposed to divide?
Okay, it's a good question. It goes to this idea that when we're adding and subtracting fractions, it's quite hard to add and subtract 2 fractions. So I'll go back to the very beginning. If I have, now those who are doing the questions, carry on with what you're doing. I'm doing a separate explanation on the side here. When I try to add a third and a half together, you can't actually do that normally, because the fractions, in order to add 2 fractions, the denominators have to be the same. They have to come from the same family, and 2 and 3 are very different. And so what we do is a process called finding a common denominator. So we change these fractions into equivalent, or fractions that are the same, but have denominators that are the same. So the way we would do it is we would say, if we took 3 and 2, if we multiply 3 times 2, we get 6. And so that is a number that both of these fractions can be made into. But I can't just do it any old way. In order to get a third to have a denominator of 6, I need to multiply 3 by 2. But if I multiply the bottom by 2, if I just leave it like that, I've made this fraction half its original size. So I have to multiply the top and bottom by the same thing. And that means an equivalent fraction to a third is 2/6. So that's exactly the same as 1/3, except that we've doubled the top and the bottom. Now we do the same trick for a half. We multiply the bottom by 3, because that gets us to 6, but then we multiply the top by 3 as well. And so now we have an equivalent fraction of 3/6. And 3/6 is exactly the same as a half. But now, because we've got the same family names, we can simply go 2/6 plus 3/6 is 5/6. So I hope that is helpful. Now, in this question over here, because the family names are the same already, I can just go 5 minus 2 is just 3/7. The second one, same idea. Because the family name, the denominator is the same. Oh, why is mine? I'm then going to get 5 minus 3, I get 2/8. Now, some of you may say, actually, I can simplify that further. And I haven't specifically said you have to simplify, but normally it is a good idea. So 2/8 can actually be written in a simpler form by dividing the top and bottom by 2. And we'll get 1/4. But both of these are equivalent fractions. There we go. Okay. And then, okay, now 3 and 4 starts to get a bit more interesting, because the denominators are not the same. Now, this is where I don't always multiply my 2 denominators together, right? So at the moment, in this question, you have 4 and 8. I wouldn't multiply 4 and 8 together to get me a denominator. You could, but what I would say is that I would really like to change the fraction 3/4 into an equivalent with a denominator of 8. And so what I'm going to do is I'm going to multiply the top and bottom by 2. And that is then going to make it 6 over 8 minus 1 over 8. And look how wonderfully simple that is. Because this fraction over here, 6 over 8, has the same denominator. And I did it by just simply choosing the right number to multiply top and bottom by. And so I'm going to get 5 over 8. Ms. Anya, are there any questions in the chat that I'm missing? Because I'm quite focused on what I'm doing at the moment. Is there anything I need to be aware of?
No, it's fine. Just the kids are doing quite fine. Just keep it up. Some of them are simplifying, some are not, and that's totally okay.
Yeah, so the simplifying is, if it's generally a good thing to do, but for today, the main focus is on this denominator thing and getting it right. Okay, last one, number 4. I see some people have got the answers already. I first want to say, what is the lowest common denominator? The only one I can see here is 35. And to get that, I just multiplied 7 by 5. Sometimes you get lucky and you can get a smaller number. By, like, for example, with the 4 and the 8, you could see that if you doubled 4, you get 8. When you're stuck, then generally we do just multiply these two to get us our number. But I still do the in-between stage where I say, well, and this is where knowing your times tables is so helpful. If you know 5 times 7 is 35, it makes life so much easier. So I would get 25 over 35 for the first step here. Now the second step, this 5 needs to get all the way up to 35. So I'm going to times it by 7. And what I do to the bottom, I have to do to the top. And so I'm going to get that. Okay, there's some hands up. Charity, I see your hand is up. What is your question? Charity? Go ahead. So let me see if I can go 25 minus 14. To me, 6 and 5 is 11. So I get 11 over 35 is what I get as my final answer.
Yes.
Okay, I see the sound of victory. It's getting harder now, though. It is getting harder. But that's traditionally, I know that students battle with this. That's why I try to convince them to do this extra step in between. For me, the extra step in between, even if it takes longer, helps you understand that you're transforming your fraction into equivalent. And then the last step is the subtraction, like that. If you wrote 5 over 16, is that incorrect? Yeah, it's incorrect, yeah. Any questions or comments? Okay, I'm going to leave multiplication out for now. Let me go to, I'm going to leave that for next lesson because it's actually not that bad. I want to focus on an extra question on the addition and subtraction for today. So what I want you to do, let's make it nice and big. I want everyone to try and calculate A to D. So A to D, same thing, just practicing those ideas. And we're still working with this idea that when we're adding two fractions or subtracting them, we really need to make sure they belong to the same family. And what I mean by that is they have the same denominator. Now, in case 1, it's all good. The family, they're from the same family. But when it gets to case 2, you have to do an extra step. And so I leave that to you to figure out. And in fact, I see now that the time has gone so quickly today that it's almost time for me to say goodbye. So we're going to have to do this. I'll give you 2 minutes for it. And we'll finish on a high. Murdy, yes, what is your question?
Sir, I would like to answer for D.
For which one?
D.
D. Okay, go ahead. Give me D.
Okay, the lowest common denominator of D is 12. So I say
Yeah.
equals to, isn't it 4 times 3 is 12? So I do the same on top and I say 4 times 1 is 1. So it's 4 over 12 plus 4 times 3 is 12. Then I do the same on top. Then I say 3
Yeah.
times 1 is 3. And then I say 4 times 3 is 7 over
Yeah.
12.
I think, okay, so I think we've got 4 over 12 plus 3 over 12, so that we should have 7 over 12. And then for the first one, we would just have 10 over 11, because 3 plus 7 is 10. For this one, I'm going to times the top and bottom by 2, so I get 1 over 4 plus 2 over 4, which is 3 over 4. And then for this one, I'm going a little bit quickly now. What do we have? We have 6 over 10 plus 7 over 10, which is 13 over 10,
Maybe, how do you like to do?
like that.
But the money is in GG.
Miss Anya, could you just put out that poll for students about what topics they've covered this term? So as we bring this lesson to a close, guys, it's been a lot of fun. Can I just say, you've done really well for your first lesson on fractions. I've been really impressed. And we're going to continue with this journey on Wednesday. But one of the things we want to do is we want to know what are the topics you've covered at school this term. We want to try and make sure we're covering topics that are as close as possible to what you've done at school. And so we've just got a little poll now where we have all the topics from maths in grade 8. And we want to see how many of, like in the first term, what are the topics you've done? So select all the topics that you've done. And then Miss Anya, if I could ask you to please get a screenshot of that at the end of the lesson, so that we have a sense of that. And yeah, guys, it's been a lot of fun being with you tonight. I do hope that you, I see you on Wednesday. And yeah, peace out. I'm going to make Anya host. Oh, you are host already, so I can.
Yes. Bye, sir.
Cheers. Cheers, guys. Please do answer the poll, and then we will see you on Wednesday, where I will bring all these things together again and we'll practice some more.
Bye, sir.
Ciao, ciao.
Goodbye, sir.